Okay, let's get started. I mean, everybody who was in early deserves to start early, right? Thank you so much for joining this session, Introduction to Windows Containers and Docker. My name is Marcel de Vries. I'm the CTO of Experience, a consulting firm in the Netherlands. You might also have heard of me as the organizer of the Global DevOps Bootcamp, one of the big events that we run worldwide, 200 venues, 10,000 people doing DevOps in a day. You might want to look out for that in May 30th. Again, it's been run all over the world. So today, containers and Docker. Let me introduce to you what the problem is that we're trying to solve. Because it's nice to learn all kinds of command line foo, but I would like to take it one step back and say, okay, what is the problem that we're trying to solve? And based on that, take it forward and then try to teach you how to use containers yourself, but also on Windows and not only Linux anymore. So what is the problem that we're trying to solve? Imagine the following. You came across this amazingly cool game, and you want to share that with your friends. And you go to your friends and you say, dude, I found this amazing game. I really want you to play it. So can you do the following steps for me? You start by installing Linux. After you installed Linux, I would like you to install a web server on there. After we have a web server, can you please open some firewall ports? Because otherwise we cannot access the website, of course. And after we've done that, we need to do some apt-gets to get some additional packages because there are some dependencies that we have. And after some yak shaving, not sure if you're familiar with the term, but it's like you're shaving the yak, and the moment you are on the left-hand side, you're back on the right-hand side, and the beard is growing as fast as you're trying to shave the beard, right? So we're constantly, what we call yak shaving, is doing all kinds of fiddly work to get our stuff actually running. That's more or less what we do 80% of our time as a developer, I think. So, and then 20% of our time we are actually productive because we're not fighting our tools. So then after a couple of hours, you're completely fed up with this thing. You say, well, dude, go away. I do not want to play your game. So what if there would be a different way of doing this? So what if I could run a command line and do something like docker run -p. I'm going to do some port mappings. I will get to that later. 9090 to 80. And I will run Marcel Vries killer app. There we go. And now what I can do is once this returns, I should be able to go to my local host, port 9090, and there we go. I can now play this great game that you probably all know and are familiar with. You can actually play it here in the browser. So I would say that I can, of course, spend some more time here playing Mario for you, but I think it gets the point across. What I'm trying to do here is I really would like to be able to package up an application, give it to you, and just run it. And I do not care what kind of infrastructure you're running. I just want you to have some base fundamental operating system in there, and you're done. And after that, you should be good. So let me kill this puppy over here, go here, and do a docker ps just for giggles, and docker do a remove. Don't mention what I'm doing now. It's just cleaning up for the rest of my demos. Okay, so it should be good for the next one. But this is more or less what we're trying to achieve. So you might ask yourself, okay, what happened here? What did you do? How did you make that happen? And this is where the magic of containers comes in. So let me dive into what containers are so that we can understand what we're trying to achieve here. And you might all be familiar with virtual machines, and we've been using virtual machines for decades, I think, now. But the whole idea is that we have an operating system that runs on an infrastructure. That might be the Linux-based operating system if we're looking at Linux. And on top of that, we can then run what we call a containerized application. What that means is if you're doing normal virtualization, you would get a new operating system booting into this virtual environment. And then on top of that, you get your application. What we're going to do here is this application is in a container, hence the blue box. It is completely isolated from any of the other applications, but it is sharing what we call the kernel. So it's sharing the operating system. So what we're doing here is we're doing operating system virtualization. And that's the big difference. So virtual machines is hardware virtualization, and containers is operating system virtualization. And it's way more efficient in terms of memory management, driver management, and all the other stuff that you normally are running into when you're doing virtual machines. Now, every application is completely isolated also inside of the kernel, so you cannot call into any of the other containers. So if you're running multiple containers on a machine and they need to communicate with each other, we will have a look at how we can actually make that happen. The binaries that you have in here are dependent on the operating system. So a container, since it's sharing the kernel, knows about the kernel, is not isolated from it, and you will create an image that is dependent on that, what we call base operating system layer that we have. And we can create many of these, of course, if we want to. Now, if we go to Windows, then the game is more or less the same. As of Windows Server 2016, and then the anniversary update, we have containers inside the operating system. And please note that I'm always talking about containers here. I'm not talking about Docker. I will get to that later, because there's a distinction between those. Everybody's always talking about Docker, but it's about containers. And the operating system has this capability of running these containers. So it's a feature of the operating system, hence we need Windows Server 2016 anniversary update or higher to actually make this work. And it also works on Windows 10 anniversary update and higher. Okay? Now we can run these applications in a container the same as we do on Linux. Now question to you, if I create an app inside a container here on Windows, can I run it on Linux? No, because it's dependent on the kernel. Okay? So it's very important to note that you have Linux containers, Windows containers. You cannot swap them around on the operating system. Well, you can a little bit, kind of, sort of, but I will get to that. Okay? Now, Microsoft said, nice that we can have this thing called a container, but what if I would be, let's say, a cloud host provider? Let's say that I would like to host your containers, and I would like to host your containers, let's say, from Deutsche Bank container, and we want to host that next to, let's say, some container coming from, what is a friendly nation? The Netherlands, okay? So we have a Dutch container and a German container. Will they fight? That's the idea, right? So what if the kernel has some kind of an exploit that they can use, a zero-day exploit, and they could break out of the container? They would be able to go to the host. They would be able to access the other container. So you always want to have some additional security if you're doing what we call hostile hosting. And for that purpose, they created this notion of a Hyper-V container. Now, a Hyper-V container still boots in this little tiny OS, but this little tiny OS is very specialized to run containers and is much, much thinner and much, much faster to start when you're running this. Now, booting this VM, which gets booted every time you start a Hyper-V container, will take a couple of seconds. Okay? And then you get the additional isolation. So you get containers, either operating system containers or the hypervisor containers. And by the way, you have some similar things on Linux if you need to. And they have more isolation or less isolation depending on what you need. So if you're running a lot of containers on your own machine, you can just use what we call process isolation. That's not a problem because you know your own containers. But if you're a hosting party, you might want to consider using these Hyper-V containers. Now, if you're booting into this little tiny OS, why not just boot into a little tiny Linux OS? And this is where the Windows platform provides you with the option to not run only Windows containers, but also Linux containers. You can run both on the operating system. Okay? Now, that capability came in as of version 1803. So we're now at 1909, so it should work pretty well on the various machines that you have. Now, Windows is in its essence different than Linux if it comes to how you spawn processes. Every time you spawn a process, you need some additional processes being alive there to do, for example, authentication, to manage the host process, and all these other things. So therefore, when you start a container on Windows, it will always be slower. There is no doubt about that Linux containers will be the fastest to run, simply because forking a process on Linux is what it's meant to be. It's been tuned for that. Windows has not been tuned for running multiple processes. It's been tuned for running multiple threads. And we probably know that from our experience running on Windows. Now, that said, they really slimmed down the image sizes. So when we started in 2016, we had image sizes of, 4 to 5 gigabytes. They're now down to 600 megabytes, and they're still slimming it down every version of the operating system. Now you see here that there is this notion of an abstraction of the compute. And here you see the Docker engine, and we'll get to that in a little while. But first what I would like to do is show you a little demo of running a Windows container. Don't you like my containers? Pretty beautiful, right? So who loves the command line? Not many, okay. You will see me in the command line a while, and that has to do with the fact that most of the stuff that we do runs from a command line if you're doing Docker. There are some visual tools around it, but I think that most people that want to be a little bit productive run the command line on it. So what I will show you first is something like this. Docker PS. That shows me all the all the container instances that are running on my machine. At the moment, there are none running. And I can do Docker images. And you can see all the images that are already downloaded on my machine that I can start. Now, what I have done, because I hate typing, is that I said, well, I would like to run this Windows Server core operating system container, but I hate to type, so I gave it a tag WSC. Okay, so what I can do now is I can do a Docker run, then minus interactive terminal. That means that I will do a standard in, standard out, redirect to my console, so it looks like I'm just going into the container and exiting out of it later. I would like to run the container WSC. And what I would like to do is then say, I would like to run a command cmd.exe inside that container. Now watch what happens. When I do this, you will see that it takes a little while and it boots up this new container. And in this container, if I do a dir, you see that my root folder of this operating system is kind of clean. This is an operating system that's kind of useless in its starting point, because you need to install all kinds of stuff in there to actually make something work. What I could do is something like this, make directory demo. I could do a cd demo. And then how do we create files on the command line? That is copy con. You still remember that? That's from the DOS age, right? Copy con myfile.txt. Then we type some text. And how do you save a file? Control C. It's kind of obvious, right? When we do dir here, you see myfile.txt, and when I do a type of myfile.txt, you see that there is some text. So this is in the container now. Now what happens the moment I do exit? When I do this and I do a Docker PS, you will see that there's no container image running anymore, no container instance running anymore. Now why is that? Because the lifespan of a container is the lifespan of the command that started it. So if I would run command.exe, it will run as long as command.exe starts. I did an exit, so the container just exited. If I would run something like W3C, then it would run as long as IIS is running. And when IIS is killed, it will then kill the container as well. So that's the way you control the lifespan of the container. Now, what happens if I would do the following? I will start a new container instance. And I do a dir. Where is my demo folder? My demo folder is gone. And the reason my demo folder is gone is because containers are what we call immutable. That means that we have an image. We create an instance of that image. So we create a container instance. On that container instance, I can do all kinds of stuff. The moment I exit and I start a new one, I get a new fresh one. So this is more or less the same as you have a C# class and an object. The class is what you create instances of. So that's the same with the images that you have. When I do a Docker ps -a, I get all the containers that have ever run on my machine. And what you see here is that I have this container that exited 32 seconds ago and this one about a minute ago. What I will do is I will do a Docker remove of 2b. I don't need that anymore. And I will get to this container instance in a while because we might want to create containers that are more useful than just the base layers, right? But we will get to that. So if you look at the container, then we have container images. And a container image has different layers. And on top of that, the moment we create an instance of the container, we get what we call a read-write layer. It's a very thin layer that just does the read-write, but it pushes it to a separate stream. On NTFS, it pushes it even to a file stream that's not visible on your OS. And what happens is, when we want to create an image that we can base our containers on, we need to find a way to use that thin read-write layer and commit it as a next layer so that I could start a new container instance based on the changes that I made. Okay? That is how we get to a base OS layer. You saw me just start the Windows Server Core base OS layer. On top of that, I could install IIS. On top of that, I can install ASP.NET. And on top of that, I can install my website. This is the moment it becomes more useful. These are the base OS layers that you normally get from your operating system vendor. Now, on top of this, we have tooling. And the tooling is the important part that I was just interacting with, because I cannot just interact with the containers just bare bone. I need some tooling to make that work. And this is where Docker comes in. So you saw me type Docker commands, and Docker, first of all, has been the company that more or less standardized everything around containers. So containers are not something new. Containers are there since, what is it, early 80s, I think, in the Linux OS and Linux kernel. They were using C groups and other stuff to create separation of the instances of the processes. And what Docker did is they came up with a standardized format for tooling, for the imaging, for storing the images and distributing the images. And what they've done is they've done it all in open source. Now, they also created a product that is more commercially, but we will get to that later. Unfortunately, I think that Docker on its own has no real future. And it has to do with the fact that they don't have a revenue model anymore. Everything is in open source, and the stuff that made them money is just sold to another company. Okay, so we will see how that will work in the future. But Docker will be probably the tooling that we will use for a long, long time. Now, you saw me already type all these commands, docker run, docker ps, docker ps -a, listing me all the container instances that more or less died on my machine. You see here a docker commit, and docker commit is what I can do is I can commit the changes that I made to a new image. And based on that, I can create new instances, so I then have a new base image that I can use. Now, if I would type this on the command line all the time, I would go crazy, I think. So let me have a look at what we call a Docker build file. Now, what you see here is that I, from the start, can start with from and then the name of the base layer container that I have. Then I want to run a command, make a directory install. Then I'm going to add some packaging in there that's an MSI that I would like to run on Windows. Then I go to the install directory and I run msi exec.exe. Don't forget to do the /qm, because otherwise it tries to pop up UIs, which is not possible in Docker. It's server OS stuff only, so it's only command line. Then I'm copying in the music store, copying in the zip files, and this is where I do a web deploy. Web deploy is the old way of running something on IIS, and this is the way I do a web deploy install on my container. Now, what happens here is that underneath the covers, it will create layers for every command that I created. So now I will have a layer, an image that has multiple layers in there where I copied in the zip file, where I actually installed the IIS server, and all that other stuff. Okay, so this is the way you can create this. And what I need to do is then on the command line docker build, I can tag it, so I can give it a name. Like I did, I gave the Windows Server Core another name by using a Docker tag and then giving it another name. You can give it any name you want. So in this particular case, it would be Marcel Vries /music store. Now let me build the container that I just created. So if I go to docker ps -a, And let me do that again so that everybody can see it also in the back. This is the container that is done, but still has state left on my machine. So what I can do is I can do a docker commit of E2. By the way, for all these commands to work, you need to have something that is identifiable. So I do not have to type in the whole ID all the time. I could also do E. And then, so commit it. Now it's actually saving it to disk. Now you see that I get an hash 2fca. If I do a docker images, you will see that I have a 2fca over here. And what I can do is a docker tag. This is the command that I used also to tag my other container. Let's tag this image as something like Marcel demo. If I do a docker images, you will see that the Marcel demo is over here. And now I can do a docker run -it of my Marcel demo, and then cmd.exe. You'll see it will start again. When I do a dir here, you see that I have a demo folder, and when I do a dir here, you see my file. I will type that file over here, and you see that there's text. Okay, so this is the way I get my stuff back once I have done something in a container. Now there's one other thing that I would like you to see, and that is the all-beloved task manager. Because what is going on when I start this container? Now when I start this container, let's run that again. You will see that more or less nothing is showing up here in terms of additional processes that I could identify. And that has to do that I'm running on Windows 10, and in Windows 10 the default isolation mode is Hyper-V, meaning that it will always start in a Hyper-V mode. Normally you don't see your Hyper-V processes here. That's the reason you don't see anything happening here. But what if I would do the following? -it, and then -- isolation. And then what I would do is specify here that it is process isolation. And now what you will see what happens is that you get these 3 processes over here, and those processes are special. And why are they special? Because if you look at the username, there's nobody on this machine. And these are the actual processes it spawned off in the kernel to do its container foo. You see my cmd.exe. If I kill cmd.exe, I will kill my container. So if you're on the host, you are in God mode if it comes to killing processes in the containers. So be careful with that. Now, question, why would I create processes with no user? Anybody an idea? It's an additional level of security, because what if I would find a zero-day exploit? I would break out of my container, get on the host. Who am I? You're nobody. So you cannot even list processes. There's an extra level of security if it comes to breaking out of your container there. And you don't need memory, no. Isn't that great? It's just for free. No, the thing is, what happens here, it's using the memory of the machine itself. Since it's sharing the kernel, it's sharing the drivers, it's sharing the memory, it's sharing everything. Meaning that if you're starting all these processes, it would be the same as starting them on your local machine, but in the kernel they're isolated, so they don't see your file system, they don't see the other processes and other stuff. What they're actually using underneath the covers is the notion of namespaces within the operating system. So they're created in a different bucket so that they can see each other anymore. Yeah. Okay, exit this one as well. And what I will do, just to clean things up a little bit, -a, and I will do a docker rm is remove. And what I will do is I will remove b5, 25, 76, and E2. There we go. So if I do a docker ps -a, it's now clean again. Okay, so my machine is clean again, so we can don't get confused when I do any of the other demos. Now you saw me using these images. Now it's always the existential, well, you just want to know where you come from, right? So where do we come from? Well, we come from what we call the container registry. So the container registry is where images come from, and that is also the way we distribute these images. So if you're in your company and you create a Docker container image, a container image, then I push it to a registry, and that registry can then be used by anybody I want to pull that container image back again and then create an instance out of that. Now there are two types of registries. We have public registries and we have private registries. And if you look at these registries, then you see that Docker itself has this notion of the Docker Hub. On Docker Hub you can host primarily public images, and you need to pay if you want to have private images. And you can also use, for example, container registry on Azure, but you can also use them on AWS, on Google. I mean, any cloud provider will have a container registry. Now, this is where Inception comes in. If you have your own container registry, the container registry is often a container image that runs, okay? So that's kind of crazy, but we will see in the Docker space or in the container space that there's a lot of inception going on. So I actually recommend watching the movie as well, Inception, and then you get a little bit of a feel of how it feels to be in a dream, right? That's more or less what's happening here. Now, the fun part about the container registry that Microsoft provides, it does a geo-distribution for you, meaning that if I would create a container image here in Germany, it will be geo-replicated to any of the zones that I would like to have it as well. So if I would create an instance next in Americas, that would mean that normally I would pull the data over the interweb, meaning that I pay for the egress, for the data out. But if it's just managed by the container registry, it's managed for you. It's part of the service that you have. Now the next step is, how do we do networking? Because it's nice to have all these isolated processes, but normally to make something useful, we need to have some form of communication going on. Now the primary way of communicating between containers is actually networking. And what is going on here, this is a virtual picture. It's not actually how it's physically laid out, but the idea is that we have this host, and this host has one network card. We just start with one network card. If we do multiple, then it becomes way more complicated. And on the machine, we have this process called the Docker host, and the Docker or the Docker daemon. And the Docker daemon actually manages the network infrastructure for you. If you're on Linux, it will use this feature called IP tables to do routing on your machine. Windows Server 2019 and later now also have this implementation of IP tables to do routing, so it becomes more and more efficient every day. Now what will happen is we can have various types of networking within Docker. Default is the bridged networking. That means that every container goes in its own network and cannot communicate with anybody else. If I would like to have two containers talk to each other, I need to create a network, and within that network I can create the containers. Okay? So that's pretty important. Now what happens is the moment I create a container instance, I will get this IP address assigned by the Docker daemon, and I can then address it on my machine. You saw me with Super Mario that I did a -P. I did a port mapping from 9090 to 80. That means that I'm mapping my local host port 9090 to port 80 in the container. So what you normally do is a container is something that you create. It has all its dependencies in there. You say, I expose this to port 80. Now I have like 5 containers on there that all say, I am on port 80. So what you need is a way to map that to the various ports on that machine so that you can communicate across these different containers. So what I can do is the following. If I go here and look at the images, one of the images that I have over here is IIS. And what I can do is here Docker run. I will do a -D so I get my command prompt back. Otherwise it will give me the interactive prompt, but for a web server it's not really useful. I will specify a port mapping and I will map port 80 to port 80. I will specify this one, and don't forget the tag, otherwise it will download from the interweb the so-called latest. That is the default. So the tags are here. So this is the name of the image, and you can have different additional tags on there. Latest is what will be defaulted to if you don't provide the tag name. Yeah? And I don't have an IIS latest, meaning that it will fetch it from mcr.microsoft.com. So now I'm starting this container. And next what I can do is go here, go to localhost, not on port 9090 because Super Mario is already dead, but here I have now IIS running. Okay? So that's the way we map the ports. What I also can do over here is if I would do docker ps, if I could only type, right, docker ps, then you see that this is the image with CE. I can do a docker inspect. This is another command that you can use to inspect what is actually running on your machine. When I do a CE, then I get a dump of what is actually running here. All kinds of information where it can find the layers, etc. And here you see an IP address. I can also go to this IP address on this machine and it will result in the same. Now what actually happened is that the -p maps localhost port 80 to this IP address port 80. What I can do is a docker remove of CE, but since the container is already running, I should issue two commands, stop and then remove, but I'm lazy, so I'm using -f, which is force. Then I will just kill it and remove it. Now you might say, okay, Marcel, nice, we now have processes, they can communicate across the network, but I have state in my application. How do I manage this? What about running a SQL server in a container? Is that possible? Yes, that's possible. There's even SQL Server available in containers nowadays, and they're even available on Windows. So what we might need is we might need some form of having separate storage attached to the container so I can store the data there. So the moment the container gets killed, the data still gets retained. Now for that to happen, I need to use what we call volume drivers. And we have various volume drivers that I can create what we call a volume mapping. So we have these different layers over here, and what I would like to do is then say I do not want to persist it to one of the layers, but I'm going to persist this to a folder on my path. For that we specify the -v option, and then I give it the host path :container path. Now what's interesting here is that I am creating this folder on my drive, and let me show you the folder on my drive over here. And I called it very beautifully the wormhole. Okay? The wormhole is where we can store data and pull data from, and that's the way we can communicate using files. Now what I could do is then say, okay, great, let's do a docker run -it, because I want to have the interactive prompt to see that the thing is mapped in my container. Then I do a -v, and I will map C:, and now be careful here, /wormhole. It's still Linuxy if it comes to its command lines. And then it will map to C:/temp. And I will do Windows Server Core. And then cmd.exe. Now when I run this, it will try to map it. And now when I do a dir, you will see that there's this folder over here, temp. Now if I go to temp, and I do copy con my file.txt, this is text in the wormhole, Control-C. Now when I go to my disk, you see that there's a myfile.txt. So that's the way you separate it from the OS. And I could, of course, do the same here. Some text file. Hello from the UI. If I only could type. Okay, save. And now when I go into my container, I can do type. And you see hello from the UI. So that's the way you get Notepad in your container, right? So you separate these two from each other. I will exit this container. We'll do docker ps, docker ps, nothing there. -a is actually what has been running on my machine. I will do a docker rm of 6. And now it's gone. So that's the way we do volume maps. And that's the way you could run, for example, a database server and have the database files on a different part of the OS. I already did that, right? Now, like I said, you might want to have multiple containers because it's very easy to create something which is a web application, something that's an API, something that's doing the caching for you, some calculations. And nowadays it's more and more popular to create these what we call microservices architectures, where we create these little nuggets of stuff that we can run. Now, containers and microservices are not something that is required to be together, but they are more or less a marriage made in heaven. So it makes a lot of sense to use containers, but it's not a requirement. So it's not that when you're doing containers, you're doing microservices, or if you're doing microservices, you need containers, but they go well together. It's like peanut butter and jelly, right? Now, if we want to have multiple containers running, you might already see that my fingers got cramped by all the typing. And you don't want to type all these containers and connect them to each other, make the networks go together, bridge the networks, and then finally they can talk with each other. So for that, the Docker folks came up with an idea and they said, why not create this notion of a Docker Compose? And Docker Compose is there to manage multiple instances of a container or multiple containers. And for that, we need to specify a file which is then the Docker Compose file. And in the Docker Compose file, we're going to specify which services we have, and a service maps to a container image, and then we'll create an instance of that. And you will get a container running that is named after the service name that you used. Now let's have a look at how this would work. So we have, for example, these 4 containers. I have a web front end, some React UI Angular thingy that we built. We have a web API, we have a Redis cache, and we have a SQL server. Now, if I would compose this up, then there are dependencies. The web front end has a dependency on the API and the cache, and the API has a dependency on the database. So I would like to create a database first, then the web API and the cache, and then the front end so that it more or less gets built up automatically in the right order. Now, for this, we have the Docker Compose file, and the Docker Compose file specifies the services. Every service has a name. We specify the image and then how we would like to build it. Now, how do we like to build it is based on the Docker file. Remember the Docker file that we have all the commands in there? And that will actually build the container image for me. And then I can specify it depends on some other services, and it will figure out which service it needs to start first. We can also specify environment variables, ports that we would like to map, networks that we would like to connect to, and volumes. That's the volume mounts that I just showed you on the command line. So how does that look? Well, let's say that I would like the web app to connect to the SQL server. Then you see that I have this music store. You all probably still know the MVC music store, one of the first samples of ASP.NET. I want to prove to you that you don't need to be latest .NET Core Ninja to actually use containers. So what I will do is I will run the MVC Music Store, which is just an ASP.NET application, old style, run it in a container, expose it to port 80, and it depends on a database. And the database is a Microsoft SQL Server Windows Developer. It's a developer edition that I can connect to. And the fun thing is that I can now specify the database name as the name of the service. So DB will become the name of the service on the network, port 1433, and that's the way I could connect to it. Then you see I have a very secure password, but it's not about security in this talk. Although I would like to mention that don't do this at home, okay? It's only allowed when you do conference talks. Well, probably not anymore, but still I try to get away with it. So, if we look at the networking, then I can create different networks. And what I could create is something like a front-end network and a back-end network, and I don't want other stuff to communicate with my back-end network other than my web front-end. For that, I create 2 bridge networks, and what I will do is I will then specify that, for example, my gaming application is placed inside both networks, making it able to connect to this as well. And then the API and the SQL data are in the other network. That way I can segment more or less which containers go in where and what is the traffic routes that are allowed between those containers. Now, when I would like to run Docker Compose, I can use these compose files and I can specify multiple of these. And that's very handy because I can create more or less the production one. And then I can create an override for debugging purposes on my local machine. So now I can do a Docker Compose with my SQL database in a container, while in production it will just connect to any of the servers that I have in my network. And then I specify up, which will bring them up. If I do down, it will bring them down. And that's the way we can then start using these containers. Last write wins is here the case. So Docker Compose override will actually override because it's the last one on the command line in this case. So let me show you that. What I have here, and I will show you a little bit of Visual Studio. What I've done is I have the MVC music store over here. This is just the ASP.NET web application. What I've done is I right-clicked on this and said Add Docker Support. I will get this Docker file. And I changed the base image to be a Windows image. So I am basing it on ASP.NET 4.8, Windows Server Core, and then the LTSC branch, which is the long-term servicing channel that's available. So it's the most stable version of the OS. Then I specify that I want to have a working directory www-root. And this is a little trick here. The trick is that the source is being passed in by Visual Studio, meaning that if I'm running debug, it will do a volume mapping to the local disk, so I can make changes to the web application without creating new containers all the time, because I can just change it and still debug into the container. It will also create a volume map for the debugger. So what it actually does is inject the remote debugger into my container, so it can connect to it. And I can actually set breakpoints in the different containers, and it will just figure it out for me. Now the copy over there, if I'm not passing in any arguments, it will go to the Docker publish folder. And when I go over here, open file in Explorer, you will see that if I go to the binary folder, to the object folder, and I go to Docker, you see that there's an empty. This is where we use the volume mapping. That's for debug purposes. And the publish, this is where my actual website is. Okay? And that will be packaged inside the container the moment I run a release build of this thing. Now what I also have done is I created this Docker Compose file over here. And you see that I have the MVC music store, which is just running on my machine. And it would normally just connect to a database that is configured in my web.config. But I also created a Docker Compose override over here. And here you see that I'm specifying an additional override here, which I created in my code, that it will fetch this environment variable over the web config. I will go to the database, and I will use the same username and password as I specify over here. So I'm creating this one with the name DB. That's the way I map to that particular other instance of the container. Now, when I go here to the command prompt, and not this one, but this one, I think, no. It's always the one that you killed. So let's go here again. Open in File Explorer, and then CMD. I got my command line over here. And now what I can do is I can do a Docker Compose. And then I can specify the file, and that is then the Docker Compose file that I have, this one. I also will specify the -f and then the Docker override YAML. And then I specify up. And when I do this, it will create the database container first because it knows the dependency. And after it booted that one, let me go here, CLS, Docker PS. I can see that the SQL server is now starting. So its health is now starting, and it will take a little while to start it up because the SQL server is actually attaching the databases, migrating the databases, and all the other goo that needs to be done on a database server that's 2 years old. And then I'm starting my web server over here. Now when I look here, you see that it's up and running, so that looks good. I didn't specify any port mapping, so what I will do is I will do a Docker inspect of A8. Then I will have this IP address over here. And now what I can do is I can go over here to my browser, specify this IP address, and this would, if all's well, start the MVC music store. Now this takes a while because it's still an old application. It will do a database migration. It will actually create a database on a database server, create the schema, inject some stuff in there. And if all is well, we would see the MVC music store booting up here. Almost. Well, like I said, it takes a while. I will get back to this. Oh, there you go. There it is. Okay, so this is the music store. This is just plain old vanilla ASP.NET 3, whatever. That still works on .NET old framework. So we don't need .NET Core, Foo, or Magic to actually make this happen at the moment. Now, when I go back here, I will kill this kill this command line. And when I do a docker ps -a, you will see that there are still some processes there. And what I can do is I can do a down. And this now cleans everything up. Okay. Now there's one other thing that we can do is we can also do a scale. I can then give it the name of what I would like to scale, and it will create multiple instances of that. So that way I can very easily scale to multiple container instances if I would like to have more requests being handled all the time. So that's the way we can use the compose commands to manage multiple instances of containers. Now this is all nice on your local machine, but you would like to go to production, I hope. At least that's what I always strive for, to actually get something in production, and preferably as fast as possible. So let's have a look at scaling. So this is the requests that are coming in, and I have more load. So what I would like to do is I would like to scale up my web frontier. And that might all of a sudden overload my API, so I need to scale out my APIs as well, get a load balancer in between there, and then finally get some additional caches. That's more or less the way I would like to scale this puppy out. Now, if I am scaling this, then that's all nice if I run that on one machine. But production is always a little bit more painful than on your local machine. And what you probably would need is multiple machines. So what you would like to do is say, well, let's have multiple machines and have something that can balance this out to the different machines. Instead of running it on one machine, I would like to have the containers distributed in such a way that I'm distributing the load a little bit. Of course, I need some network load balancer in front of that to actually make the balancing work. Now, what happens? Oh, those are load balancers internally to route the traffic internally in the host. So what happens when this host dies on you? Or you might do a Windows update there and you need to boot, right? Reboot the container. So in that case, I want something to take care of the fact that these containers need to be moved to another host, so I still have zero downtime if it comes to doing upgrades or making changes to my configuration. Also, when I have a new version of my container, I would like it to be distributed across those nodes, start it up, and then drain the traffic in before new traffic is moved to that node. Now, for that, we need what we call a container orchestrator. And we would like to have container scheduling. Scheduling is looking at who is busy, based on that, schedule it somewhere. And the orchestrator is monitoring the cluster and knowing where stuff is, and based on its health, making decisions to reschedule stuff. Now, there are many cluster orchestrators out there. And this is also where you see things coming in like Docker Swarm, Azure Service Fabric, DCOS Mesosphere, Fleet. There are many of these products out there. There are also some by Red Hat that are pretty popular these days. But there's this war going on if it comes to these orchestrators. And I think that there is a clear winner. And this is an opinionated part, I would say, but it's more opinionated about on the fact that we see a lot going on if it comes to Kubernetes. This is also why I think Docker is dead. Because everybody moves to Kubernetes, and Docker Swarm more or less was doing the same that Kubernetes is doing. So why would I pay a gazillion bucks for something that's free in open source? Now you have a gazillion bucks that you need to spend on consulting, I think, but still, it's free, so everybody goes there, right? Now you might ask yourself, yeah, what about Docker Swarm? And I think that at the moment you still see Docker Swarm used a lot in the field because that was the first incarnation of good, solid cluster orchestrators, and you see Kubernetes now more or less taking over that market. Then the other party over there is Service Fabric, and Service Fabric is a little bit special. And why is it special? Because all these orchestrators are built to manage what we call stateless workloads. That means that I can just throw away a container, start a new one, and it will be managed for me. There is no notion of state. But Service Fabric has this specific programming model that we can use, which is called the actor model. And if you program against the actor model, you have what we call stateful services. Now, Service Fabric is, because of that, a little bit special. There is still a reason to use Service Fabric, but if you have the choice and you have a stateless workload, then you're probably better off using Kubernetes nowadays, I think, because that's where the market is going. And everybody announced, like Docker announced, Red Hat announced, everybody announced Kubernetes support. So that means that it's going somewhere, right? And that's an important thing. Now, if we look at using Kubernetes, then you can build your own clusters, which is a lot of fun, a lot of hours that you can spend on the command line to make these clusters work. I loved to do that a year ago. It was one of those things that you spend your Sunday when it's raining. But nowadays we have this notion of a cloud, and you have cloud providers, and all these cloud providers now have this notion of a managed Kubernetes service. So you have them on AWS, you have them on Google, and you have them on Azure. And on Azure we have what we call AKS, Azure Kubernetes Services, fully managed Kubernetes cluster. You only pay for the worker nodes that we create, so those are the additional virtual machines that we need to manage with a machine scale set. You can let the upgrades being managed by Azure for you. And there's also this notion of what we call a virtual kubelet, and this extends the whole model in, okay, I do not want to pay for compute. I only want to pay for compute cycles that I'm using. Now, Microsoft has this offering called Azure Container Instances. Then you run a container, and once it's done, you get the data back. Container died, and you only pay for the CPU and memory. Now, if you connect what we call the virtual kubelet to your Azure Kubernetes cluster, that means that you can start instances and only pay for the server compute and memory that you consumed and then be done, instead of having a node that you need to pay for that is running more or less all day. And that's very useful for burst loads that you might have. Now, from the command line, we can use another command line tool which is called kube control, of kubectl, depending on who you ask. I think that's the same word as tomatoes and tomatoes. But kube control is the tool that we can use to create what we call deployments. So you remember that I created this Docker Compose file where I have services that I specified? Well, in Kubernetes, that's more or less the same. You specify which services are you interested in, which deployments do you want to create, and then after you have these deployments deployed to your cluster, you can then see them running, and it will handle the scale for you as well. And it will also manage things like rolling updates. So if I have a new container, I can make the change, and it will nicely remove a container, get a new container in, and reroute the traffic for me. And it's all done for me without worrying about it anymore. Kubernetes has this notion of desired state configuration. So what I do is I tell it what I want. It will take care of the deltas for me with the right commands. Meaning it needs to spin up stuff, it needs to kill stuff, it needs to reconfigure stuff. It will take care of that for me. Now, when I do kube control, what I could do is the following. Let me go to my browser first. So here you see that I have the Kubernetes dashboard. And on the Kubernetes dashboard, you see that I already have IIS running. But what I will do is I will do the following. CLS. Kube, CTL, delete deployment, IIS. And what will happen is it will take care of removing IIS for me. It's not in the cluster anymore, and it will remove all the traffic and all the other stuff. And what I would like to do is I would like to show you deploy IIS over here. This is what I specified. So I would like to create what we call a deployment. That deployment is IIS. I want to have a number of replicas. That's the number of instances I would like to have across my cluster. Then I can specify the labels. It's IIS, so I can get to it when I need to. And I'm using the container image, mcr.microsoft.com, blah, 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 LTS 2019. Then I'm specifying container port 80, and I want it to run on a Windows node. Now, AKS has this notion of a mixed cluster. I have Linux nodes and Windows nodes, and this is the way I specify it needs to schedule it on a Windows node for me. Now, what I can do here is then go to my directory over here. CLS, I can do a kubectl, then I can do an apply. I specify the file, deploy IIS, and when I do this, this is the desired state configuration that I'm interested in. It will then go out, will try to create IIS for me. What I can see then is that it has this set of pods that it will create for me, and this is where you see IIS is now running. So IIS is now running, but how do I get to it? Well, what I can do is I can say on the command line something like kubectl expose. I would like to expose a deployment. And which deployment will I like to do is IIS. And I'm going to specify minus port equals 80 and minus type equals load balancer. This will now specify that it will create a new service for me, and a service is the way to expose something to the outer world. It will now go to the load balancer on the cluster, which is the AKS load balancer. It will then allocate a new IP address for me where I can then connect to this service. So this will always take a little while because it needs to reconfigure the actual load balancer for me. Now the other thing that you see here is that I have the music store running here. I have it already running on my cluster. And what I would like to do is I would like to make a little change here in my file over here and say music store from Basta. I will save this. I will commit this. If I only could find commit over here. Commit demo. Commit all. I will sync this to my Git repository. And then what you will see is that I have over here Azure DevOps completely configured to pick up this pipeline. So this commit is now being picked up. It will now build this container for me. If I look at this pipeline and edit it, you will see that what I will do is I will build it. Then I will do some Docker commands. I will build it. I will tag it. I will log into my Docker registry, push it to my registry, log out. That's the way I push my image to a registry that I can then fetch the information. And once this is done, I created a release pipeline. And this release pipeline actually then takes the artifact. And then, of course, no fear, just go to production right away, right? Then what I will do is I will do a replace tokens on my configuration file. And I have a configuration file over here, deploy music store. And this is where I'm saying that I would like to have 10 instances of the music store. I would like to do a rolling update, so it will take care of picking out one container at a time and rerouting traffic for me. Then you see that I've given it the label over here, and then the containers, they will be fetched from the Docker hub. And you see the build identifier here is what I need to replace, because that's the ID of the new build that was just finished. So that way I get the exact image that is in my container registry. Because every time I push it, I will give it an extra tag. And once this finishes, I should be able to look at that container running in a few moments. Now, I will finish this off by, like I said, there's no place like production. And the only way I think you should go to production is not using the command line. You should not be typing kubectl all the time and all these things. You should try to refrain from that as much as possible. I would urge you to create a CI/CD pipeline like I just showed you, because the CI/CD pipeline creates you something that is really something you can rely on. Every time you do a commit, it will be pushed to production. Every time it happens, it will go the exact same way. And if it hurts, do it more often, because that's the way you actually get good at it. You manage your code with a Git repository, either using Visual Studio Code or Visual Studio, whatever you'd like. And what we do is we build these container images. So instead of creating these installers, instead of creating these scripts that we install our applications, we create Docker files. The Docker files will result in images. Those images will be pushed to a registry. And then I have my configuration file where I say the desired state of this Kubernetes cluster has this deployment. You get these services from these locations. It will do the pull for you, and it will manage the rerouting of the traffic for you as well. And then you can deploy to various environments. I often see people still use dev, test, acceptance, pre-prod, whatever. I think you should rethink that, because that's bringing the old habits into a new era. I think that is more about the quality gates that you want to go through. Instead of doing something like pre-prod and stuff, define it as what is it that I want to achieve in terms of confidentiality, confidence level that I have in my application. Is it UI testing? Is it unit testing? What is the quality gate that I'm going through? And based on that, it's then ready for production and move it to production using a simple command line. Now, if you go to the CI/CD pipeline that I have over here, you see that the apply so I replace the tokens of my file, then I do a kube control apply, and I will move it then to the cluster. I will specify this is the YAML file, and it will actually do the kube control for me. Now, if all is well, hopefully it is done, so that's good. And now I should be able to create a release here. Create. Release 46 has been created. It's now been queued. Here I can go to the music store. You can see, here the pods. And the moment this is done with its initial task, so it's now replacing the tokens. Once that is done, it will do the kube control apply. If all is well, I should then see over here deployments, refresh. You see the music store is now moving. You see the pods over here, that there are new pods being scheduled. Waiter on container creation. The others are still there. So if I go to the music store, you will see that the music store is still there. By the way, you see the deployment over here, which is 7B85. And what it will do is it will replace it for me on the go. So if I go here and refresh a couple of times, you see the container is running, but it's not healthy enough yet. And eventually, it's too slow today. Yeah. It will take a couple of seconds, and then it will drain the traffic to that actual node, and then we should be done. And that's the way we deploy to these clusters. Yes. And with that, I hope I showed you a whole lot of stuff if it comes to building containers on Windows. Wrapping it up, I hope you've seen a lot of Docker stuff on Windows. Kubernetes as the way to go if it comes to the cluster where you want to deploy to. Also, Windows containers nowadays supported in preview. And then Azure DevOps as the way to actually move things to your cluster in a secure and compliant way. With that, I would like to thank you. If you want to read more of this stuff and do some of this stuff at home, I created multiple of these courses that will help you get into shape if it comes to continuous delivery and DevOps. I am using Azure DevOps for that, so these are all Azure DevOps courses that you can find on Pluralsight. If you want to know more about containers, then please go to the Introduction to Docker on Windows. It still states Visual Studio 2017, but it's not old at all. It's just the stuff that I just showed you today, but then go into a little bit more detail, a little bit slower pace, I would say. With that, I would like to thank you so much for coming. Hope you have a wonderful conference, and hope to see you next time. Thank you.